Hey, I'm going to do one more example, or actually two, one of each. One square root function, one cube root function to show you the effects of AH and K on the graph. Okay, so the first thing I'm going to do is identify which family this comes from. This one is negative square root of x minus 5. Which family? That's just the regular square root family. So it's that rainbow family, right? So my graph, in my mind, I'm thinking square root function, okay? And that's the parent family it comes from. What is A? What is H? And what is K? Well, in this function, you might want to stop and pause and write them down. But A is negative 1. So don't be deceived just because there's not a number out there. There is a negative 1. H is under the radical. Well, this one doesn't have one, so H is 0. What is K? K is negative 5. Okay, so what effect do the AH and K have on this parent function? Well, A is negative 1, so it's not going to stretch it taller or flatten it out, is it? But it is going to reflect it. So this is going to reflect over the x-axis. So that means it's going to fall underneath the x-axis and go under. What does H do? Well, H has no effect, so it has no horizontal movement. Okay, no horizontal change, but the K is the vertical change, or up, down. So this one's going to go down 5. Okay, so let's see. If I go to graph this, what's it going to look like? Well, the parent graph is going to be reflected. Instead of being over, it's going to be under because it's reflecting. Now it's also going to shift down 5. So instead of being at the origin, it's going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and it's going to reflect under, and it's not stretching, and there is my graph. So now you guys can see what this graph would look like. Now let's do one more. And this time we're going to look at the cubic function. Okay, whoops, I didn't mean to erase those, but I'll knock this out real quick. Let's change A, H, and K. This time I'm going to make this 1/3 x minus 3. And this is going to be a cube root instead of a square root of x. Hopefully you can see that, plus 1. Now this has lots of transformations, doesn't it? We have the 1/3. Well, let's start at the beginning. Family. Which family is this? This is the cube root family, or the snake. Okay? It's the snake through the grass. The A is 1/3. The H is positive 3, and the K is 1. So what was at the origin is going to shift to HK, or 3, 1. So this new spot, instead of being 0, 0, that's going to change to 3, 1. Okay? Now, what effect does the A, being 1/3, have? Is it going to stretch it, or is it going to kind of shrink it and compress it? It's going to compress it. So it will compress this closer to the graph. Well, it was already close to the graph, so it's even closer to the graph. Okay, H is going to be a horizontal shift, positive 3. That means it's moving to the right, right? Because it's positive, so it's going right 3. K is positive, so that means it's going up 1, a positive 1. So let's do a quick sketch of this cubic graph. Okay, here's an XY coordinate, or a Cartesian coordinate plane. I'm going to regraph the 0, 0 to be at 3, 1. So 3, 1 is where it's going to change, and it's going to be very tight to the axis. So it's going to be very long and skinny. What is the domain and range of that? Well, all cubic functions, or cube root function, domain is always all the x's from negative infinity to positive infinity. It goes on forever, doesn't it? versus the range, it's going up slowly and down slowly forever. So it's negative infinity to positive infinity. So the domain and the range for all the cube roots are all real numbers, both for the range or the domain and the range. It keeps going up and down. So let's see. I still have another couple minutes. So let's talk about domain and range of the just the square root function. It's a little more limited. On the last one, I didn't have an HK, but this one I'm going to have both shifts so you guys can see what happens to my domain and the range when I have shifts. Okay, let's look at the square root of x plus 2 plus 5. Okay, so I like to draw myself a little sketch. I think it's easier to do domain and range if I have a graph. So what was at the origin is going to shift to HK. I have an AM1, don't I? So it's still going to be square root function, and it's not going to stretch it, or it's not going to flatten it and compress it. It's going to stay the same at the same curve. But my HK is negative 2, positive 5. So that means I'm going to start at 2 and 5. Okay? I'm sorry. Negative 2, positive 5. So it's got a left shift 2 and an up shift 5. And my curve is going to curve like this. Okay, so what is my domain? Well, domain is your x change. What happened? I took it from 0 back to 2. So that means it's all x's such that x is greater than or equal to negative 2. So I'm starting at negative 2 right here on the x-axis, aren't I? And the graph is going this direction. See how I'm bringing it down to the x-axis to see where it starts? It's everything to the right. All the x is greater than 2. I can do the same thing with the y value or the range. What's the range of this? Well, there's nothing down here. I start the graph on the y-axis here, and I keep going, what? Up. So I'm starting at 5, and it's going up forever. So the range is all y's such that y is greater than or equal to positive 5. Okay, so notice what's happening on this domain and range. My domain is affected by my h, isn't it? Because it's my y change, or my x change. My range is affected by k because that's my k change. So notice this is starting at my h and this one's starting at my k. So there's my helpful hint for the day. You guys have an assignment and it's page 263, 1 through 4, 13, and 15. Let me jot this up here and then you guys can work on it. I'm going to sit in the Class Connect time and help you if you need it. So, page 263, 1 through 4, and 13 and 15. And if you want to read some more examples, there's some in the book. Have a great day, and I'm here to help you.